Now, as I told you that chromatography means the chroma means the color, graphy means to write, and Mikhail Samonovich and Sweat, he was the first Russian Italian botanist who invented chromatography in 1900, and in 1901 he presented his work, that is of the separation of chlorophyll pigments, in the conference, that is at the 11th Congress of Naturalists and Physicians in St. Petersburg, and he published his first paper in 1905 on chromatography. In 1905, that is, this technique is about 120 years old, and the second paper of the separation of chlorophyll again in the German Botanical Journal, Berichte der Deutsche Botanischen Gesellschaft, and in 1907 he was able to make the first chromatograph for the German Botanical Society. So, Sweat was named by various because he was a Italian, he was a Russian, and German influence also. So, his name was spelled by various forms like Sweat, TSV, Sweat, and Sweat. All these you can say they look like similar, and in 1911 he left the world. So, this is, that is, chromatography in the beginning was idea is you take any chromatography, it involves two things. Any chromatography involves two things. One is the stationary phase and the other is the mobile phase. Stationary phase, it may be a gas, it may be a solid, it may be a liquid, and the mobile phase also, it may be a liquid, it may be a gas, and depending on this stationary phase, different types of chromatography they are classified. So, I have a I have some animations for you, and you can see like this is the stationary phase. And this is the loading of the column or any stationary phase, and here the material is loaded onto the column. This is a very this is the mixture of the products. And here comes the mobile phase. It saturates the column, and the particles they move with the mobile phase, and they are collected, and they are separated. That is, you get the different components of your mixture, and that is, these are the separated products. So, that is how the separation takes place. So, the main thing is, that is, you need a stationary phase, you need a mobile phase, and you can use chromatography for the separation of the impurities. So, chromatography, it makes the separation of components in a mixture based on polarity, boiling point, ionic strength, and size. That is, polarity, you can have interaction with the solvent, you can have interaction with the that is different substances, like in gas chromatography they change into vapors at different temperatures, and ionic strength means they have different interactions, they have different mobilities at different ionic strength, and size also as they move in the mobile phase, and that interact with the particle that interact with the solute particles, or that interact with the sample. So, mobile phase is very important, and it is the phase in which sample is dissolved, and it may be a gas, liquid, or any fluid, and stationary phase is the phase in which mobile phase is passed through it. That is, mobile phase and stationary phase, these are the two important and the analytes, they distribute themselves between the two phases, that is, they distribute in the stationary phase. So, partition, most of the chromatography is based on partition chromatography, and what is partition chromatography? That is, mainly it is used in GC and LC. Partition is that is your liquid mobile phase, liquid mobile phase is coming, and the substances or the solute molecules, they distribute themselves in the stationary phase and in the liquid phase. They distribute themselves in the liquid phase and on the solid phase, and this distribution of the solid solute in the liquid and on the column is, that is, in the mobile phase and on the stationary phase, is known as partitioning or partition in chromatography, and you can consider it as a partition chromatography. So, another is based on affinity, that is adsorption chromatography, that is similar to partition chromatography. Different solutes, they are adsorbed on the solid surface of the column to different extent. So, it is that is, and another is ion exchange chromatography. In this chromatography, that is the stationary phase, have different sites and it may involve the exchange of the ions. There is separation of cations and anions may take place, and then this chromatography is named as ion exchange chromatography. That is, on the surface of the stationary phase, there are some specific ion exchange resin sites, and you can exchange cation or you can exchange the anions. So, ion exchange chromatography and molecular exclusion chromatography. Molecular exclusion chromatography is based on the size, that is, small molecules, they are more get trapped in pores and take longer time to get out of the surface. And another is again, that is separation is based on size and charge, that is smaller molecules will migrate further and they are less tangled, means they are having less interference, they move faster. So, gel and affinity chromatography, that is, this is also it is applied for the biological applications, that is specific binding sites they are used to concentrate the analytes on the column. That is, specific binding sites are used to concentrate analyte on the column. So, this is affinity chromatography, and it is used to separate the proteins or some enzymes, and like this, there is some sites we apply, and then we can elute them. So, there are some specific sites, that is proteins or enzymes, they are retained and impurities are washed out. So, these were the different types. Now, what is the theory of chromatography? Main thing I told you that chromatography involves the distribution of the solute in the two phases. Okay? That is, it involves the distribution of the solute in the mobile phase and in on the stationary phase. So, we can consider the distribution constant, and there is a counter current experiment, retention time, and the relationship between the distribution constant and the retention time, and capacity factor K dash and selectivity factor alpha. Another thing is like in basic chromatography, what we have a mobile phase, we have a stationary phase, and mobile phase passes through it, and depending on as it passes through the mobile phase, as it passes over the stationary phase, then we come to the detector part, that is in after the column. In detector part, depending on the response of the materials, depending on the response of the solutes, signals are recorded. So, and we get signals in different forms, and there are various types of detectors for chromatography. So, the signal comes in the form of a Gaussian peak, and their shape, column efficiency, that is how much it depends on the plate height and the number of plates, and the kinetic factors. They are described by the Van Demeter equation. So, first I will explain you what is the retention time. So, it is the time taken by the analyte to reach to the detector after the sample injection. It is denoted by Tm, that is, it is the time taken by the analyte to reach to the sample, to reach to the detector after the sample injection. And the materials which are not retained on the column, they are they reach to the detector, and the retention time of the material through the column which is not retained, that is also called as dead time or dead volume. Dead time or dead volume means कि भाई आपने एकदम इंजेक्शन की, ठीक है, and material is not retained, it is not going any attraction, any adsorption, any reaction, that is no mechanism is taking place between the solute and the stationary phase, that is the analyte and the stationary phase, that is known as dead volume. So, Tm is the length, that is the velocity of the rate of migration, is the average rate of motion of the mobile phase molecules, that is length of the column, or Tm. that you can say. So, different distribution constant you can find out, velocity you can find out. So, all these parameters, that is velocity, that is, and number of analytes in the mobile phase, and the total moles of analyte, relative, that is velocity, and this you can calculate from these equations. And capacity factor K dash, it describes the migration rate of analytes in the column. And capacity factor also means that it is the normally how we judge that this is the concentration up to which we can use the column. If your peak starts broadening, that is, they start increasing in size, like this last one, this, and if it starts more broadening, then you can say that you are reaching towards the saturation limit. And capacity factor, that is, it describes the migration rate of analytes in the column. So, selectivity factor, depending on the between two species A and B, that is, you can distinguish between A and B which substances, that is, you can selectively separate, that is known as the selectivity factor, and it depends on the choice of the mobile phase. That is, in this factor, that is, in at a particular mobile ratio, one substance may show a higher peak, and at the other ratio it may be retained on the column. So, selectivity factor is also very important. So, that is how the peak broadening takes place, that is, peak keeps on increasing. And peak broadening is not a good signal, means peak broadening takes place only when you have either saturation or you have a strong interaction of your solute, that is analyte, with the mobile phase. That is, your mobile phase is not able to elute your solute or your analyte, that is at that time peak broadening takes place. Another thing is column efficiency. Column efficiency means size of the plates. I will explain you that as the solute or as the analyte moves, we consider it as this E, that the whole column is made up of a large number of plates. Plates means there are some sections in which solute, that is analyte, is distributing itself, and this depends upon, we can describe this thing as a theoretical number of plates, and greater the number of theoretical plates, greater is the separation. And theoretical plate is n, and it is given by L over H, that is length of the column, and peak height, and typically theoretical, that is n, that is number of plates is 250 to 10,000 in a column. And so, kinetic factors also play a very important role in the separation, and kinetic factors means temperature, column composition, mobile phase, and if you, at what rate you are increasing the temperature, pH, mobile phase, flow rate, pressure, concentration and particle size. That is solutes, and that is the what is the particle size of the column, that is 5 micrometer or 10 micrometer or 2 micrometer, different columns are, and depending on this, if we plot a graph between plate height and linear velocity, we get this type of the graph. And there is, after there comes a decrease in as the velocity increases. First there comes a dip, and then this is almost linear with the velocity, that is plate height increases. So similar, all of you know that when there is a, in chromatography there is a equation, that is the flow of the liquid is not uniform in the, because column is fully packed, and this diffusion is known as Eddy's diffusion, and we can define, we can give it by the Van Demeter equation, which is H is equal to A plus B over U plus Cu, and that is we have to consider A, that is eddy diffusion. That Eddy's diffusion is, that is zigzag or movement of the analyte in the column, and due to different paths it has to take. And B over U is the longitudinal diffusion, that is it diffuses in and against the direction of the mobile phase movement. And Cu, that is it is broken into two terms, that is mass transfer coefficient, normally we call it CSU and CMU, and that is total Van Demeter equation. Now question is how band broadening it can be reduced by decreasing the particle diameter, that is we take the smaller analyte molecules. Decreasing column width means we decrease the column width, and lowering the temperature and minimum thickness of the liquid stationary phase. And another thing in chromatography, very important in chromatography, is the resolution between the two peaks. And the resolution between the two peaks, that is between any two peaks, this A or B or A or B, A or B, that is this is given by 2 into TRB, that is migration time of B component minus A over divided by mass of A plus B. So resolution, that is the separation, and depends on this, and this is not a resolved peak here, it is the submerged peaks, and most of the analytes, and you have to work on it to separate it into different depending on the polarity. So this is the so I told you that stationary phase is very important, and depending on that anion and cations, they can be retained, and depending on that we have positively charged and negatively charged columns, and on that separation can take place. So in HPLC, how the separations take place. First, I will show you a better animation. First is, this is your pump, these are the solvent, this is the column, and it is the detector. Detector is connected to a computer, and the absorbance is taken in case of UV absorbance detector, and the plot of absorbance versus time, that is known as a chromatogram. The instrument is known as chromatograph. You can see how the substances, they come together, and they are detected, and they are separated. Another thing in chromatography, the more important is the troubleshooting, that is identifying the problem while using a problem. If you get this type of the peaks, it means that mobile phase is not suitable. Mobile phase, that is, it is the your analytes, they are not dissolved completely in the analytes, they are not dissolved completely in the mobile phase. Their motion and their velocity is not uniform, or there is a clogging in the column, and this is baseline. And if you get a baseline of this type, that is, there is some contamination of mobile phase, or there is improper cleaning, that is, this is the normal baseline in case of you take any detector, and this is little bit noisy peaks. Similarly, if temperature is not stable, then you can get these types of peaks, that is and contamination of the column. And if your peaks is merged together, that is this type of peaks, that is this is due to the improper mixing of mobile phase, and problem is, that is 90% problems are due to the improper mixing of the mobile phase. There may be a bubble in the mobile phase, and these 30% of the almost of the problems are with the column, that is column is not clean. Then this is peak tailing, it is known as peak tailing, and after you adjust the pH or other things, this will you will get and this type, if you get peak of this type, this is known as peak fronting, means peak gets distributed towards one side, and this happens at the low temperature, overloading, and flow rate is not uniform, and insufficient mixing of the mobile phase. And if you have a very high concentration, that is, there is a flow of the mobile phase, that is that is there is this is overloading of the column, and this is that is you are having very high concentration of the sample, then you have to move to the towards the lower concentrations. In chromatography, in HPLC or in liquid chromatography, the main important thing is the retention time, and based on the retention time you can identify a analyte. You can identify one of the components in a stationary phase, and if this is not constant, means look here, this is not constant, and then it is due to the and you are getting peaks of almost the same size, then these are due to the problems of the mobile phase. And if you get any communication error with the software, you have this type of the problem, and this is also the problem of the mobile phase, and you do not have complete separation. So if there is power fluctuation, you may get this type of the peaks, and area may be not constant, or sometimes in HPLC or in liquid chromatography, we get the peaks which are not due to which are not due to the sample, and they are coming in the impurities in the mobile phase, and these peaks are known as ghost peaks, or and they upset the equilibrium and production or this is due to the impurities or contamination of the mobile phase. And if you get peaks of this type, there is a constant response or there is a negative response. These are due to the lifetime of the detector, that is your क्या कहते हैं वो बल्ब जो है उसका डिटेक्टर का उसकी सैचुरेशन टाइम आ गया, एंड देन यू हैव टू चेंज द बल्ब ऑफ द detector. So applications of HPLC, there are many applications of HPLC. First I will compare HPLC with the main difference in HPLC and gas chromatography is that liquid chromatography can be applied to both volatile and non-volatile substances, whereas gas chromatography is applicable only to the volatile substances, and gas chromatography can be applied to non-volatile substances by making their derivatives which are volatile. ठीक है, अगर हमारे डेरिवेटिव्स वोलेटाइल हों, उनको नॉन वोलेटाइल हैं, बट इफ़ वी make them volatile by coupling it or by derivatization, then we can analyze them. So this is the main brief introduction to chromatography, right? I would like to show you an animation. In this, if you like it, it is good. Otherwise, I will stop it, and it will show how chromatography, or how you can use HPLC chromatography before going to the lab. I will explain you different I will explain you different steps. So this is an Agilent chromatograph, and हाँ जी एक मिनट. So, the mobile phase, that is first step is filtration of the solvent, and after that we filter the solvents, and that is how we fix the uh, on the flask, on the this bottle, and this is the filter through which we pass the mobile phase. So, we pack it, and first we take, then we connect it to the vacuum pump, and so that filtration may take place. We filter the solvents, and that is how the solvents are filtered. And then we you see that is the filtration is taking place, and after that we degasify the mobile phase, that is these and we fill them in the HPLC mobile phase bottles. And this is the sonicator. You sonicate your mobile phase so that it has no air bubbles or no air dissolved in them, and after the sonication uh, 782881 ਤੁਸੀਂ ਦੇ ਦੋ ਬਸ 78 1332 1332 782881 782881. Now we filter the analyte sample, and everything, that is it should be filtered through 10 micrometer filters, and this is how we make the samples up to 2 milliliter, you can say. But generally we make the samples, we fill the sample vials to a constant height. In we take the same amount of sample during the analysis, and then now we come to HPLC compartment. Now this is now let me explain you. This is the solvent system, where the you have the solvent, that is the mobile phase. This is the pump where you can apply up to 3000 pascals the pressure, and this is auto sampler. Auto sampler means it is injecting automatically your sample, and you have the injector. Then this part is the column, and here you may set the column, and from the column this is going to the detector, and from here the fraction collector, or you can have a waste collector which is coming from the mobile phase after the from the column. So, this is how the HPLC system looks like. Now, we take the we degasify or मैं बुढ़ा हो गया यार. We degasify the solvents, and we first we क्या कहते हैं, see that there is no bubble in the in the pump, and we clean it, and then we inject the sample. This is the sample holder of the normal HPLC chromatograph, and then you can go further, and this is how the fraction collector. Then you are connected to the software, where you can start the software, and you can fix, you can make your program, and the method for the analysis. You have to make a method for the analysis, and you have to select a suitable wavelength. You have to select suitable wavelength of the analysis. In a normal quaternary chromatograph, normally you have you can select 4 wavelengths depending on the maximum absorption of the analyte. And other thing is that in case of continuous diode array detector, that is diode array detector, the instrument itself selects the suitable wavelength for your analysis. That is how you make the program and for your analysis. This is with diode array detector. And how the description looks like, that is all the components which you have to adjust, all are you can set with the help of software. Then this is the setting the wavelength and on the for the detection, and there is the instrument is almost ready for the analysis.
अगर अननोन सैंपल है तो वेवलेंथ स्कैन मोड में भी कर सकते हैं?
हाँ जी, वो तो स्कैन मोड में जो हमारा डायोड एरे डिटेक्टर है उसमें तो हो ही जाती है मैम हर एनालाइट की. You can have the spectra of unknown analyte. Otherwise, you have to select and compromise, make a compromise with the selectivity or selectivity of 4 wavelengths where it is available. Like we have, then we load the sample. Sample is automatically loaded. This you have to learn how to make a sequence on the chromatograph, and then your analysis is continuing is start. You can start the instrument. So, this is how the instrument is running, and you can have your analysis done. this is this is dead volume, or you can say this is the system peak, means it indicates as the analyte comes out of the column and it reaches the detector, it gets detected and you will get a peak. That is how you get the different peaks in your, and when the system is, when your analysis is finished, you this is the peak, and these are at 4 wavelengths, at different 4 wavelengths you can generate the report of the instrument.
तो solvent peak भी आएगी इसमें?
सॉल्वेंट पीक तो मैम शुरू में ही आती है ना, ये वाली सॉल्वेंट का मतलब थोड़ी बहुत छोटी मोटी जो इम्प्योरिटीज होती हैं, स्लाइट स्मॉल डेड वॉल्यूम जिसको हम कहते हैं ना, कि भी एज इट कम्स आउट ऑफ द कॉलम, दीज आर दोज थिंग्स, सिस्टम पीक कहते हैं इसको.
अदरवाइज हम नॉर्मली सॉल्वेंट पीक बड़ी नहीं होती है HPLC में, कि ये ऑटो सबट्रैक्ट करके उसको
Normally acetonitrile do not absorb in this range, methanol do not absorb in this range of the, that is above 200, and for more clarity you can subtract your baseline from the analysis peak. For more clarity means you will, and for that purpose you have a very nice column, and the mobile phase should be very nicely prepared and no impurities should be present.
This is the reason why acetonitrile, methanol, they are preferred as
Yes,
suitable solvents.
yes, they do not absorb in the UV region. Now in HPLC, the analysis time is very high. It is 15 minutes or 20 minutes. Then there comes a competition that we should decrease the length of the column. We should decrease the length of the column, and back pressure, or to solve the back pressure, and so depending on that a new system was developed, and that is by decreasing the size of the column, and this technique was named as UPLC, ultra performance liquid chromatography, and it is equity system or other, that is UPLC systems are available. We have a UPLC system in our science, in our instrumentation room, and that is the analysis which was done in 10 minutes, now it can be done in 3 minutes only, and depending on almost with the same resolution, and with the same with the same accuracy, and only thing is that there is less use of solvents. So, this HPLC, it can be applied to drug discovery, that is, and molecular weight confirmation, purity, and we can analyze the different samples. So, I will introduce you how I will take 5 minutes more. We have analyzed, we have developed methods for various analytes like fluoroquinolones. These are the various fluoroquinolones: ofloxacin, lomifloxacin, sinoxacin, nalidixic acid, and these are separated, and we have analyzed these in chicken or any other in various samples. So, we have tried to decrease the retention time also, and you can see that separation is now complete in 12 minutes, whereas earlier it was in 25 or 30 minutes. And similarly, we have applied this to urine, water, hospital waste, and various pharmaceutical samples, chicken muscles, aldehydes. Also, we have analyzed various aldehydes using HPLC and SPME, because aldehydes are very important. And similarly, we have cinnamaldehyde and benzaldehyde, which are present in the cinnamon bark and in the bitter almonds. There is this cinnamaldehyde and benzaldehyde are present. So, we have found them in almond samples also, that is, in almonds cinnamal and benzaldehyde are present. So, this is about the HPLC, means because before knowing how LCMS, you must know both the components, liquid chromatography and mass spectrometry. So, now you can have a training in the chemistry department on HPLC system and solid phase extraction, and at 2 p.m. I will introduce you how we attach mass to the LCMS and how can we solve the different problems. ठीक है, thank you very much.